Hello, I'm Soonyong Park, who will present about VIDEX, the artificial intelligence-driven video indexing for rapid surveillance footage summarization and review program. Before looking at VIDEX, I will explain why AI technology is needed in the investigation stage. When an investigator analyzes a surveillance camera, there will be objects or abnormal behaviors that he or she wants to see intensively. However, unless the video is viewed from beginning to end, a person cannot determine whether an object or abnormal behavior appears in the video. Therefore, we thought that we should enable efficient investigation by allowing computers to detect objects and abnormal behavior rather than humans. That would allow the investigator to spend much more time on the investigation through the summarized video than on the video analysis itself, and the accuracy of the investigation would be higher. Therefore, we designed VIDEX that provides easy access to objects and abnormal situations that investigators want, and summarize only those parts to reduce investigation time and increase investigation efficiency. Next, I will tell you about the system design of VIDEX. The interface structure of VIDEX follows the C# WPF MVVM pattern. The view is responsible for the parts shown to the user, and the model includes domain data. In the view model, processes are carried out using the data of the model, and the result information of object detection and outlier detection is contained in the database. Next is multi-thread pipeline. Since image data consists of multiple sets of image frames that change continuously over time, it consumes a lot of time in processing. VIDEX effectively processes such data through a multi-threading method. In the object detection part, video frames are divided by the number of threads, and YOLO process is applied to the divided frames to obtain the desired result. In outlier detection, threads are allocated as many as the number of detection models, and each thread is subjected to video segmentation, applying pre-trained 3D CNN model and detection method to obtain the desired result. Last part is database. Since VIDEX uses the database, object detection and outlier detection result information can be contained in the same structure, and a further optimization attempt can be made to improve the loading speed using the database index mechanism. As a result, faster retrieval and summarization of the object and outlier detection results can be accomplished. Now, the interface of the VIDEX program. First, this is the setting view screen. This screen contains features such as video input and player, a video option panel for time edits, and an object filter panel. The second is analysis view screen. This screen displays object detection results. It includes a result of creating the bounding box of the detected objects, a thumbnail image gallery, and last, an appearance graph indicating which parts of the video the objects appear in. Lastly, this is the anomaly detection view. This screen includes a graph indicating which part of the video detects abnormal behavior. Before the demonstration, I will briefly explain the object detection and outlier detection by the VIDEX program. VIDEX identifies objects through the MS Coco dataset of 80 common categories. The user can manage the list of objects through the checkbox in the user interface. In the future, we plan to add weapons categories and properties of specific objects such as color and car models through the transfer learning. Also, we will add algorithms to track and organize objects. Next, VIDX outlier detection. In order to detect abnormal behavior in the video, we use the anomaly detection techniques, assuming that the abnormal behaviors like as depth, assert, will be detected as the statistical outliers. For the detection stage, to conduct a proof of concept, we employ prominent non-parametric outlier detection methods, such as local outlier factor, cluster-based local outlier factor, and isolation forest. Each detection method is modularized and can be replaced with other generalized outlier detection methods. From now on, I will demonstrate a VIDEX program developed based on Windows system. The screen you see now is the setting interface at the stage before starting the analysis, and here is support setting the input data required for the models. And we will test the abnormal behavior dataset from AI Hub, which provides public dataset necessary for AI technology development. This dataset is about 5 minutes of CCTV footage, especially depth and assert. Now, we will suppose we become video analysts. Okay, let's get started. First, let's load the video file we want to analyze. Now, let's check whether the video has been loaded properly. Then, let's check the object list. This panel is used to pre-select objects to display on the object detection results screen. These objects is 80 categories in the MS Coco dataset, and these objects are used as total classes in the Euro model and the database index not only selected. So even if user is not currently selected here, user can adjust it in the following analysis window. So there is no need to search again. And then, set the video length of the section to be analyzed by entering the start time and end time. Now, let's start analysis stage. After completing the setting, the following two screens appear. One is a window showing object detection results, and the other is a window showing outlier detection results. These two detection processes operate in parallel, and you can see it being loaded in real time until the work is done. So let's take a look at the object detection results first. Now, object detection loading process is done. The object detection window can be divided into three things: output video containing yellow detection results, object gallery, and appearance graph. First, through the video player, it is possible to check which objects have been detected. Then, let's use the gallery function. These all images are linked to the object table in the database, and each of these objects contains video frame information. This object search is possible along with the video frame. And since each object class indexed, filtering is easily possible. It can allow the user to better analyze the desired scenes. This information can also be expressed as a graph that shows the number of times an object appears in the graph. Therefore, these functions are pretty easy to utilize as analysis results. The results of this analysis can be summarized with object detection and outlier detection process. When you run a summary, the index results of each processes are automatically combined. This is saved as an image and video file and can be easily checked. In reality, these can be very useful as evidence in CCTV investigations. Back to the program. Finally, the results of this analysis can be extracted in the local directory through the Summarize button. And if you go to Save Directory, there is a chart image with filtering applied and an output video. The following is the outlier detection result window. As you can see in the graph, to reduce noise in the detection results and facilitate better understanding of the summary video, we apply padding before and after the time axis of data points classified as anomalies. And this provides outlier values for depth and assert scenes from 4 to 10 seconds shown in the graph along with the video frames. These outlier values can also be saved as an image and video. Lastly, our future work about VIDEX. As mentioned earlier slides, we will conduct a dataset transfer learning plan and tracking algorithms. Additionally, we plan to do optimization work to make the execution speed faster. Thank you for watching our presentation.